All right, we're ready to get started. Welcome to another DevNation Live. And I got to tell you something right now. Hopefully you're listening to us right now because this is a brand new platform. We have no idea if we know what we're doing at this very moment, but we're going to show you some excellent content and have a great presentation from Edson Yanaga. Now, one thing that's different about our new platform here for 2020 is that you have a chat window.
All right, we're ready to get started.
And you'll want to make sure you can chat and see us there. So make sure you hit that URL. I see Prasad has already sent us a message.
We have no idea if we know what we're doing at the very
That is
moment.
fantastic. So chat looks like it's working. So what
I
I want to do right now is turn it over to Edson Yanaga and let him get started. Edson, go.
2020 is that you have a chat.
Hello, thank you, Bert. It's very nice to be here on this brand new platform broadcasting to you. And today we're going to talk about distributed data. So if you're talking about microservices and you want to know how to use, consume, distribute, integrate your distributed data, this session is for you. So let me share my screen here. And I hope you can all see my slides. My name is Edson Yanaga. My Twitter handle is @Yanaga. I also happen to be a Java champion and a Microsoft MVP. And just in case you want to follow me on Twitter, that's the perfect time so you can take a picture with your phone of this QR code and you can follow me, because in the next upcoming months, I'll be sharing a lot of content regarding the subject of today, distributing your data with CQRS, event sourcing, and a lot of different technologies. And just to give you another resource, I published this book from O'Reilly approximately 3 years ago. So this was the starting point for my research. So a lot of things that I'll be discussing today, well, they are the next step from the initial step that was this book. So this book is a great addition to your talk. So if you want to know what I'll be talking about like in a deeper way, you can read the book. So you can go to bit.ly mono to microdb. And the quote that I get from my book is, code is easy, state is hard. Because when people are talking about distributed systems, they talk about the behavior, they talk about the code, they talk about how they would going to distribute their artifacts. But in my opinion, state is always the hardest part. So how can I distribute my data? How can I consume this distributed data? How can I integrate? How can I correlate that? I think this is harder. So I'm not meaning that code and behavior are easy. I'm just stating that no matter how hard or how easy is that, state is always harder. So the typical use case when people talk about microservices, that if I want to consume, I distributed my data. So I have a remote microservice or a remote monolith, and I have a new artifact, which could be another microservice, and I want to consume the data that is available on the other endpoint. The typical use case that most people present is that we are going to consume the remote data in a synchronous way. So we have a synchronous data retrieval on a remote endpoint, and typically people are using synchronous technologies like HTTP REST or gRPC, or if you're very old school, you could be using RMI or IIOP. And this is a bad approach. So this is the thing that we're going to try to convince you to not do, because whenever you use a synchronous communication protocol to retrieve the data on a remote endpoint, you face issues like, for example, latency. You used to have your data locally, so now you have at least one order of magnitude higher latency when you're reaching a remote endpoint, because now you have the network. Also, you have availability issues. If your microsystem, your microservice, to be able to perform well, it needs the other endpoint to perform well too. So it needs to be available and also needs to be performant. So you have all of these three issues when you're trying to retrieve data remotely, and when we try to solve these issues, we usually think about caching or polling. So now I need an internal cache or a local cache of the remote data, and I'll need to update this data in a certain frequency, which also includes some kind of polling strategy, which just complicate this stuff. Distributed systems are already hard, we're just making it even harder and trying to use this approach. But the good point is that we are going to, whenever you add cache in between your microservice, you need to use eventual consistency, which is something that definitely we will have to embrace if you want to use distributed data properly. So if you're thinking about strong consistency all the time, well, maybe you need to change your mind, because now with this distributed world, eventual consistency is the king. But before I give you the solutions to this problem, let's try to give you a brief of context. So first, let's take a look back in the past. How was data managed 10, 15 years ago? So 10, 15 years ago, at least in the Java world, we were terrified about entity beans. Then we had something called Hibernate, in particular Hibernate 3.0, which was released in 2005. So it means 15 years ago. And people just realized that, well, let's get all of this metadata that was in separate files, in XML files, and let's put them inside our code. So we replaced XML hell with annotation hell, which many people, including me, might argue that it's better because we learned that this metadata is required, and the closer the metadata is to the data, the better for maintenance purpose. So we replaced XML with annotations, and because of this Hibernate approach, we also realized that we're able to use POJOs, plain old Java objects, as they are an Anemic domain model. So we started creating entities that were just placeholders for data. They didn't have any behavior. They only had getters and setters. But also in the software architecture community, at the same time, like 15 years ago, we were also discussing a new term called event sourcing. Event sourcing is much older than that. Event sourcing could be like 30 or 40 years old, but the name event sourcing was only being discussed like 15 years ago in the past. And I'll have to explain you very briefly how event sourcing works. So suppose you have money in your bank account. That's not the way that you would model the money in your bank account, like having an ID, a customer ID, and a balance. You would, in traditional banking systems, you model the amount of money in your bank account with transactions. So you have transactions, and you have an account and ID, you have a debits and credits operations, and then you have the amount of money that you performed in that transaction. So if all bank accounts start with 0, and you have a credits operation of $1,000, and you have another debit operation of $300, and then another debit operation of $150. If you just add and subtract the amount, you know how much money do you have in your bank account. And when you think about that, this is what we call event sourcing. We're not representing the current state of the data as a single row and a single column in our database. We're representing the state of the data as a stream of events. So we have a lot of consecutive events like transactions, the credit and debit operations, and if you compute all of the transactions over the time, we know the current state of our data. This is what we call event sourcing. And the nice thing about event sourcing is that it enables you to think the events that happen in the system. So instead of modeling the structure of the data, we can think about the behavior of the data. And be with me. Another concept that I also introduced to you is CQRS, command query separation. So when we're talking about modeling operation on our systems, Bertrand Meyer in his book Eiffel stated that asking a question should not change the answer. So you should model the operations in your systems as either command operations or query operations. Within a command, you're demanding your system to do something, probably you're demanding a change of state. And with a query operation, if you issue like 10 consecutive queries to your system, the answer should always be the same, assuming that the data didn't change during this time. So with events, we think about the same. You should have like a command events and query events, but for the purpose of this talk, we're going to only to discuss the query events. And if you're thinking about your code, whenever you're designing your Java or C# interfaces, you should have command interfaces and query interfaces too, which means that you would have like separate Java interface for all the commands and separate Java interfaces for all your queries, which is a best practice because now you know that in the past, these Java interfaces would be implemented in the same class. And since now we're talking about distributed systems, it's very common for these interfaces to be implemented in different artifacts and probably different technologies. And after CQRS, we also coined a term called CQRS, Command Query Responsibility Segregation, which was coined by Greg Young approximately 10, 12, 13 years ago, which is a very fancy name for a very simple data access pattern. So how does it work? In the traditional CRUD pattern, you usually use the same model for read and write operations. I'm writing a customer, I'm reading a customer. So this is a very simple architecture. Actually, it's the one that we recommend for you to start your application. But later, you realize that, well, maybe I can have different models for my read responsibilities. So the traditional approach is this. You have a customer table and you insert into customer using all the fields and you select star from customer. But whenever you have new requirements and you want to create custom queries because of performance, for example, you don't want to retrieve all of the customer data into memory if you just want to show the, for example, the ID, name, and phone of the customer. And in another screen or another report, you just want to show the address. So what do you do in each one of these cases? You create custom queries. So for these custom queries, ID, name, and phone, and then ID, name, and address, these are custom read models that you're using in your application. So what can we do? With CQRS means that I'm using customer class for writing operations, and I'm using customer DTO 1 and customer DTO 2 for reading operations. This is a typical CQRS architecture. And the one that I want to show and explain today is CQRS with separate data stores. Because in the previous example, I was showing how you create separate queries from the same data store. I'm using the same set of tables for the reading. But if you think about that, I'm not constrained. I'm not restricted to using always the same set of tables because I can write the information in one data store and I can read the information from another data store. Examples? Well, for example, I could have created a view or a materialized view. I could be issuing the queries against these views, which means that I'm writing the information to the customer table, but I'm reading the information from these separate views. So you have a write model, customer table, and you have two separate read models, which is customer report view and customer billing view, for example, in our model. And how do I combine all of these terms, CQRS and event sourcing? And remember, CQRS means I have separate models and potentially separate data stores for read and write operations. And event sourcing means that the state of the data is a stream of events. I don't represent my data just as a snapshot of the current state. I represent my data as a stream of events which can be persisted or just stream it through a message broker, for example. So how do I combine all of these things together? Well, here in the banking system, for example, how would you do that? You would perform the write operations on the transaction table, which is below here. So whenever you're withdrawing or adding money to your bank account, you would write this operation on the transactions table. But if you're reading something, you would probably query the read model, which is the bank account table. So if you want to know how much money do you have now, you go to the balance. If you want to change something, you write to the transaction table. And some way, somehow, internally in the banking system, you get these transactions, which are the events of your system, to update your read model, which is the account table. So the account table is the read model, the transaction is the read model, and somehow you get these transactions, these events, to update your read model. And I'm using a very specific model here because the credit and debit operations are a very special case of event sourcing. But if you're using something simpler, for example, if you're just using a customer entity, or like an order entity, you could create events like, for example, customer created, customer updated, or customer deleted, which is a much more common example of event sourcing. Okay, so when we're discussing CQRS 15 years ago was used because of performance. But now that we are in 2020, we can find other usages for this CQRS pattern. So now let's back to the future. So now we're in 2020 and we're using CQRS for distribution, availability, integration, and analytics. And how do we do that? So suppose that you create your own new microservice. you create your customer microservice. And we call this customer microservice the canonical source of information for customers, which means that this microservice is the write data store for the customer information. If you want any write, it's going to be done inside the customer microservice. But then, you know that many other endpoints in your system require the customer information. Maybe not the entire customer information, maybe just a subset of the customer information. Maybe for the shipping service, you only need the customer address. Maybe for the notification service, you just need the customer's email address or phone number or Twitter address. So different microservices have different requirements on which pieces of the customer data they require. But all of this data is stored on my canonical source of information. And how am I going to model that? Instead of going to the customer microservice every time I need to retrieve the data, the customer data, I'm going to use this customer data locally, which means I'm going to create a local CQRS read data store inside my own microservice. So suppose that we have the shipping service and the notification service. They will have their own copies or subsets of the data of the customer information locally. And I need a way to propagate the changes that are happening in my canonical source of information to my read data stores. And how do I achieve that? I achieve that through events. So whenever I create events, could be transactions or could be create, update, and delete events, I need to broadcast these events to my remote read data stores. And how can I propagate these events to my remote endpoints, to my remote microservices? So we have some approaches, and this is what I'm going to share with you today. First approach, you can, you can use HTTP per REST, HTTP in general, for a synchronous event retrieval. So how does it work? You have the canonical source of information, which is your customer endpoint. And here on the client's microservice, where you have the shipping service, which is the consumer of the information, I issue an HTTP request to the remote endpoint. And I retrieve through this HTTP plus REST interface, I retrieve all of the events that happened since a certain timestamp or a certain ID. So how would it work? Instead of queuing, give me the information of customer Bird, and retrieve all of Bird's information and then process that for the shipping service, what would I do? I already have Bird here. And I just determine like a polling interval, like every 30 seconds, every 1 minute, every half an hour. It really depends on your system requirements. But suppose that we decided that we want a cron job here, and every 10 minutes I want to check if the customer address changes. So I go to my remote endpoint and ask for this information. Hey, customer service, I have all of the data changes since 10 minutes ago. Can you give me all the data, the data change events that happened since this particular timestamp or this ID? Yes, of course. And then I get the list of events, I process all of these data change events, and I update my local database. That's how it works if you still want to use an HTTP plus REST endpoint. So in this particular architecture, you would still have your traditional REST endpoint here, which would include the entity, and forgive my writing, but you would also create another endpoint which would just retrieve the events that happened since a certain timestamp or certain ID. So yes, you can use HTTP per REST if you want to use events and create CQRS with the store. I have to admit that this is not common architecture, but it's perfectly achievable. So you don't need to have a broker in your architecture. You just use HTTP, which everybody is using these days. You can create a REST endpoint which will export information in JSON or XML. Everything. You have all of the skills that everybody's used these days, and you can still create CQRS remote architectures which are very efficient used in this traditional way. But you can also use another way. You can use an asynchronous event propagation, which means that you need a broker. You need, for example, an AMQP broker such as ActiveMQ, or you need a distributed log, for example, like Kafka, to propagate the events, the data change events from the canonical source of information to your client's microservice. For example, the shipping service in this case, instead of going and trying to fetch the information, the change events, instead of fetching, it's going to receive automatically the events whenever any kind of data changes. So, it means that I could have the immediate propagation of the data change from the remote endpoint to my local endpoint. So yes, so one of the nice benefits of using asynchronous event propagation through a message broker, for example, is that instead of having to poll the information, and if you're polling periods like 10 minutes, it means that the latency between potential data change until you fetch the information, until you receive the change, is up to 10 minutes. Like, could be less, but it's up to 10 minutes. But if you're using a message broker like MQP or Kafka, it means that whenever somebody changes the event, this message is going to be written in the broker, and you're going to receive that with a very low latency. Of course, it's a lie if I'm telling that it will be instantaneous, but you have like latency in the order of milliseconds, or if at most a very few seconds between you had the change of your data until you get the change in your remote endpoint. So if you need very low latency on your remote endpoint, probably this is the architecture that you want to use. Okay, so yes, asynchronous event propagation is another approach that you can use in your microservice architecture. So right now, I'm trying to assemble, and have in mind that this is a very short list because we don't have much time today. But remember that later, in the upcoming weeks and months, I'll be sharing more content about it. So it's another reason for you to follow me on Twitter. So I'm trying to create a prescriptive list of steps or approaches that you can use in your architecture to be able to achieve this distributed data usage. So first step in your architecture, you need change events. So in one way or the other, you need event sourcing. And when I say you need event sourcing, I don't mean that you need to store the data in your application as event sourcing. You just need to be able to create an event sourcing whenever something changes in your data. Whenever your data changes, you need to create a string of events that can represent the data that is stored in your system. So you need event sourcing. So you could still be storing your customer information, for example, in your traditional CRUD way, but you would need like an interceptor or a database trigger saying that every time the customer information is updated, I'm going to create an event saying, oh, the customer was updated, or the customer was created, or the customer was deleted. So which means that you have to create some sort of event sourcing. In this particular case, you have two particular options. You can change your application code or your application architecture. If you're using Hibernate, you could create a Hibernate interceptor, or you can change your application code to be generating your events, or you can use a very nice technology called Debezium. And Debezium is a CDC2, a change data capture 2, which doesn't require you to change your application code to generate this event sourcing. So basically, you plug directly Debezium in your database. It reads the database transaction log. And whenever you have an insert, update, or delete statement on a certain set of tables, Debezium is going to read that information from the log and create a corresponding event and propagate this message on a Kafka broker. So yes, one of the requirements that you will need Kafka, which means that you will be using asynchronous propagation for that, but it could be a benefit on the other way too. So remember, to generate your event sourcing, you have two approaches. Change your application, either the code or some part of the infrastructure to capture those events, or you can integrate Debezium in your architecture, which is particularly one of my favorite approaches. Okay, and you can go to the Debezium log, And Debezium solves all their harder problems using Kafka, for example, dual writes or something like that. You can go to the Debezium blog, which my friend Gunnar has a very nice writing on how to use the outbox pattern to solve all sorts of problems. And second step on our approach, you need to distribute the events. So regarding the possible solutions that I've presented before, how can I distribute the events in microservice architecture or distributed architecture? You can use two separate approaches. For example, you can create a REST endpoint for your event using Quarkus. You just create a REST endpoint, and these your REST endpoints will propagate the data traditionally as you think as a REST endpoint, but these REST endpoints will also be able to retrieve the change events that happen over a certain period of time. So this is another, and I'm saying Quarkus, of course, you could be using Node.js or Spring Boot. I'm using Quarkus because it's my favorite technology these days, which is a super fast and super small Java framework for your applications. And another approach is that if you don't want to publish a REST endpoint for your event, as soon as your event is created, you are going to write this event on a message broker, which could be possibly ActiveMQ or could be Kafka. Okay, so you need to propagate the events. You need a way to publish your events. And third step, you are going to consume the events and update your local CQRS data store. And suppose that you're the shipping service and you're receiving the event either through REST or through Kafka. You're receiving that event and you have all the customer information on that event. What you're going to do, you're going to filter the piece of information that you need. Oh, I just need the address of the customer. You're going to get that piece of the change event and you're going to store in your local database. Okay, that's the third step. And fourth step, you're going to use your local data, which is stored possibly in the same database as the other data of your microservice. And you're going to use the joins, you're going to use the SQL queries, you're going to fetch everything from your local CQRS data store. That's the practical approach for being able to use and integrate your data in a microservices distributed world using CQRS and event sourcing. And I know I might have rushed a lot of concepts for you, but remember, all of this content I'll be sharing with you in much more detail in the upcoming months. If you just follow me on Twitter, you'll be able to get all of this content firsthand because it will be published in our resources. And of course, it will also be published in the developers.redhat.com website. And that's what I had to share with you for now. I hope I still have some minutes to be able to some questions. So I'll be giving control back to Bert to see what's happening.
We do have a couple minutes for questions. I'm looking to see if anything's come in. At this point, though, Alexis did notice during your presentation that you took the logo from the uTorrent software for your little U, for your microservices U.
Oh.
Look at that.
Is that a logo? Because I just typed micro.
Yeah. So I didn't go verify that particular thing.
Mm-hmm.
I did post a link to your book, so people have access to that, as well as Gunnar's blog, so the Outbox Pattern blog, to make sure people have access to that. And I'm looking to see if any question comes in here. It does take a moment for it to respond, so we'll give it another moment or so. But Edson, from your perspective, what some other key resources for people to go drill down on? Like, what books would you recommend besides the book that you wrote, or what other blogs would you recommend?
Mm-hmm. It's interesting because I've been researching and reading a lot about this event-driven architecture stuff in the past months. And the books that I found about event-driven architecture were written like 10 or 15 years ago. And most of the concepts that I read on these books, they don't apply on these modern architectures that we have these days. So I find we're missing some pieces, and I hope I'll be able to fill these missing pieces in the upcoming materials that I'm writing. But of course, some key concepts that you need to learn are, I think, there are domain-driven design to be able to know which pieces of information you can distribute. And of course, if you want to be very sharp on the technologies that are particularly requirements for distributed data worlds, I would say that learning a message broker like Kafka and creating proper endpoints for REST is another one. and yes, and CQRS and event sourcing. So yes, you need to check all of these boxes to be able to create like a performant architecture, a feasible architecture for your distributed data.
And I added the link to Domain-Driven Design, Distilled. That's a common book that people really love from Von Vernon as an example. And so that will give good information for folks. Michael Henderson responds with, thanks. He likes this new format, this new way for us to run these kinds of shows. Okay. Okay, a quick question. One more question, and we're kind of out of time, but let's kind of hit this one. How to manage consistency in the data model. How to manage consistency in the data model when there are different teams working on different services.
Okay. When I'm saying consistency, I suppose it's the ability to handle conflicts, right? People are writing the information. And first, in this particular model that I'm proposing, and that's what I write, what I wrote in the book, that's maybe it's another important resource. You don't have data conflicts because everybody is writing to the same endpoint. So that's number one. And then for consistency, when you're dealing with the remote endpoints, the consistency will be always strong eventual consistency. You never have conflicts. What might happen is that the information that you're storing locally is staled, which means that it's outdated. You didn't get the latest data changes, but the information is correct.
In this case, though, I think the consistency is around schema, not around user data. So DDL versus DML.
Okay. Around the schema?
Yeah.
Then it's a more complicated thing because when you talk, I think it's like the schema of the events, for example, right? And when you're talking about the schema of events, you have some options. You can use event versioning. So you need to be able to propagate the event on a previous version for a certain amount of time until you can guarantee that everybody's using the later event schema. Or if your schemas are compatible, another approach is that you can add an intermediate step in your event queue, for example, and implement something using Camel to convert one schema version to the other. That's another approach. But of course, as any architecture question, the answer is always it depends. I would need to study the particular user case and propose a proper solution. But these are two common solutions to this problem.
Well, there's one more question, then we have to go. What about at least once message delivery? So if you're thinking from a message delivery, message-oriented middleware perspective, at least once, that's semantic. What would you recommend for that scenario?
At least once. Well, okay. For the broker, well, both brokers would support at least once.
Yeah, I think all brokers pretty much support that.
Yeah, at most once is the MQP. But if you need at least once, I think all brokers technologies would support that. And at least once also means that you can have repeated messages being delivered to your remote endpoint. And then you just need to implement the idempotent consumer pattern just to check, oh, did I process this event already? If yes, then just ignore.
Okay. No, I think, and that's all we have time for today, but I think that's exactly where that question was going. Hopefully I got that interpretation correct. And then, of course, the consumer has to deal with the fact that it could have the message more than once, right, in the at least once category. And actually, I'll drop a quick link into something related to that. Camel has an implementation for dealing with at least once as an example. Okay, well, we are out of time for today. We do try to keep these things to 30 minutes. I thank you so much, Edson. It was an excellent session. We had a little bit of interaction on our chat. Hopefully we'll get this technology figured out, and we'll be broadcasting more of these sessions in the future. Do look for us on the Thursdays. We run these on Thursdays, basically the first and third Thursday of the month, about noon, and that's kind of what we're trying to focus on. So you'll see another one coming up here in February. Okay, just to make sure you pay attention to our DevNation website, right? So developersirate.com/DevNation. That'll get you access to future information, and of course, if you're part of our email list, you'll get access to that information too, and I'll add the link to the website in the chat. All right, well, thank you guys so much. Edson, thank you.
Thank you. Bye.